All right, guys, welcome back to Math Analysis here on April 14th. Hope you all had a good spring break. So what we're going to be talking about today is points in a function that have that are not in motion, that are not changing. Now, for full disclosure, what we're going to be doing is kind of skipping a little bit in our packet. Currently, we've made it through problem 12, and then the concept of which we're talking about today relates to the questions that are like 21 and on in that section. We're in this class going to be skipping the ones from between 13 to 20. Those are kind of more of the same of what we've been doing, but just with a little bit higher difficulty level and more derivative rules. It's much more a calculus thing than I really want to get into in this class. So we're just going to skip right on to 21. That said, we're not doing that problem today, but we'll be talking about the ideas behind it. So the questions on that section of the packet ask about what points are not changing. So here's what we want to think about. If we have a line, or if we have a function, just like a regular old parabola, right? I'm going to just draw one of those here. What point would not be changing? Well, to think about this, we need to identify what the slope would be of a point that's not changing. Well, a point that is not changing would have a slope of 0, right? It's not going up, it's not going down, just a slope of 0. Well, that makes us think, well, what does a slope of 0 look like? A slope of 0 looks like just a flat line, right? That's a slope of 0. So where on this parabola would we have a point whose slope would be 0, whose slope would be just a flat line? Now let's remember, to graph the slope, or to look at the slope of any given point, we create a tangent line to that point, right? So we would have to be able to draw a tangent line, a line that does not intersect other than just one individual point that's flat. Well, a lot of you guys may already be thinking this, but that point would be right there at the very top of the parabola. I'm going to try to draw this line where it intersects. Oh my gosh, I did it. Heck yeah. So we have this point right here at the very peak that if we drew the tangent line, it would cross through that one point and it would be flat. It would have a slope of 0. It means that point is not changing. This makes sense, right? Like if we think about it as it relates to parabolic motion of projectiles that we were talking about back when we were still at school. We said that whenever you throw something, if you're throwing a football, right? You throw that football up, or a basketball, a free throw, whatever. You throw that up, and once it hits that peak, it stops moving, at least in the y direction. And that's what slope's all about, right? Slope is all about how's it moving in the y. So whenever that basketball reaches the peak, before it comes back down towards the basket, it stops. It has that split second, that one point where it is not in motion. It is not changing. And then gravity hits it and it begins to fall, and we know how all that works. But it stops for just that split second. And that's what we're going to be identifying in this next section of derivatives, is we're going to be taking functions, finding their derivatives, and using those to determine what points of the function is it not in motion. So I'm going to label that here. And what we are going to do is tomorrow, I think I misspelled changing. Ignore that. I would edit that out of the video, but I need to learn how to do that. So, what we're going to do is tomorrow we're going to take a function, probably a pretty straightforward, simple function. We will graph it, and we are going to use derivatives to identify those points that are not changing. We're going to see the math side behind this. But what I wanted to talk about today was just strictly the idea behind it, the concept that points that are at the height of parabolas, or even if it is a function like this, if it is something like that, points that are at these sections are not in motion or not changing either, right? It is that split second when something changes direction. That's probably a really good way to think about it. Whenever you have the basketball and you're shooting it up, when it hits that top point, it begins to change direction. It's no longer going up anymore. It's starting to go down, right? In that point where it changes direction, it's actually not moving at all. In something moving in this way, I don't know what's actually going to move like that. But if something was moving like this, when it has that point of changing direction, then it stops. And it does that exact same thing here. So we're going to see the math side of it tomorrow. We're going to graph some of these. We're going to see how we find it with derivatives. But if you have any questions about this, feel free to let me know. Otherwise, see you guys tomorrow.